It had been a busy weekend, and there had been sizable outbreaks preceding Saturday, Sunday, and Monday, particularly the previous day. And I know on that Tuesday morning, it looked like at least it would be a comparatively quieter day in the sense that at least there weren't expected to be as many large tornadoes. A tornado threat certainly was some severe threat.
And so the idea of an extreme Cape setup was becoming obvious there across East Texas even the day or two before that. And so even though the low-level flow was going to be weak, I think there were several people here that at least were concerned from the perspective of, it's May, it's Texas, we're going to have this extreme instability, very rich low-level moisture, but the forcing is going to be weak, the low-level shear is going to be weak. We think the main show will be up near the Red River and then over into northern Louisiana and so forth, but if we can get something to develop farther south, we've got to watch it. But honestly, I don't think anybody, even in their wildest dreams, expected what happened. I think most of us thought there might be a rogue storm down there that would produce a brief touchdown due to the convergence along the boundary, and then that would be it.
To me, it was just going to be another day in Texas where, sure, storms will go off. There'll be some severe, violent tornadoes. I can tell you, I saw nothing. I had no idea how that day was going to pan out.
But there was also still, a decent area of buoyancy, very strong buoyancy across the southern plains, particularly there in central and eastern Texas. And there was a large overnight MCS that had moved across a large part of Arkansas. This MCS had produced a real well-defined gravity wave, which was moving southwestward, perpendicular to what was essentially a stalled dry line, had a weak, shallow cold front kind of catching up to it there in central Texas.
I mean, first and foremost, it was just so unstable. That's always got to be the first thing mentioned when you talk about the Gerald event. Again, dew points near 80, temperatures near 100 along this boundary.
So the Cape was really about as high for a 2-day period over a large area, eastern Oklahoma, Texas, than you would typically ever see.
And the pattern that day, because the main shortwave trough had passed to the east, the flow at mid-levels had relaxed some, and particularly the shear by standard climatological means, we were on the edges of the bell curve. The deep shear was not that strong. I don't remember the exact value. It may have been 20 and 25 knots. There was westerly flow at mid-levels, but it was very weak as far as we could tell. We were trying to examine the profilers that were available and the VWPs, and there was nothing to suggest there was going to be a stronger or an enhancement of the westerly flow during the day. But there was, a decent veering profile, but the low-level winds were real weak. But that kind of buoyancy just caught my eye. We did end up issuing a tornado watch and then subsequent ones later. And no one, when we issued the watch, expected the evolution that did occur, namely the progression of supercells sequentially developing southwestward, propagating southwestward in tandem, not necessarily caused by, but in tandem with this gravity wave that I mentioned, in such a way that the updrafts were able to evidently take advantage of what low-level shear was there, and certainly through some form of stretching process did indeed go on to produce very strong tornadoes. And then an environment, again, that by conventional wisdom at that time and even today would have suggested that there was no way that was going to happen.
The southwest motion was unusual, but far from unprecedented. I would say a handful of times a year, we see these low shear environments of high Cape in which we'll get a storm to form. It's typically in Iowa or Kansas, and it backbuilds zippers southwestward along the boundary, and they're commonly associated with landspout tornadoes. I think what was more interesting was just the internal storm morphology of getting these small landspouts to form, and then, how on earth did Mother Nature spin that up into something much more interesting than just a landspout tornado?
I think the real surprise was getting a violent tornado with that much weakness in the shear profile, no matter how deviant the motion was. I have yet to see anything other than perhaps, some people say that Plainfield was a lot like this too, where Plainfield tornado in Illinois had a fairly marginal 20 knot flow at 500, but it had the 8,000 Cape. I think those two tornadoes in Jarrell and Plainfield are two huge outliers on the side of massive instability and marginal shear. Even in real time, the degree of damage that was being reported was, I think, shocking to us.
I don't think any of the convective allowing models, the HREF members or any of that stuff, they would have probably given us better definition as to where the storms would form, and maybe even the southwestward development along the boundary. That things like that they might have done pretty well. Yeah. And from a pattern recognition, we might have seen that in the model and said, oh, that's one of those landspout setups. And so maybe we would have played it up a little differently in our products. But in terms of intensity, no chance a model would have given us any guidance that would have been useful to tell us the scale of the event. That was unprecedented, and I hope it remains that way.
The case serves to illustrate that we don't know as much as we think we do. 50 years from now, 100 years from now, people examining this case are going to say, my gosh, those guys were asleep at the switch. Couldn't they see that this was going to evolve this way? Because we understand now what was going on that particular type of environment. It gives us a sense of humility so that we don't go around thinking we know more than we do just based on our limited set of data. As good as it is, it's going to be augmented in future years, and kind of keep our mind open to the potential that things can happen and evolve in ways that you don't necessarily think are possible, and never totally close the door on potentially a high-end event if you have one or two of the necessary ingredients that we do know, and certainly high buoyancy is one of them, to produce such an event. It teaches the forecaster and everyone not to take their jobs in a blasé manner, to really, every day you don't know when something significant could happen. Always be looking out at the ends of the distribution, and don't take the science that we think we understand completely too seriously. Then understand that people 100 years from now are going to be doing our jobs, and we're going to look as quaint to them as, say, the meteorologist of 1922 looks to us today. And
on a level of fascination and uniqueness, it's definitely a top 10 convective event, because I really felt humbled.
In terms of ones that just kind of sear into your mind that you're going to remember forever, Jarrell is definitely one of them.